Okay, today's first lesson on really what I would say the more sophisticated portion of this unit, cardiovascular system, and that's going to be the rhythm of your heart and the beating of your heart. So what I would like to begin with first is the sequence of excitation. I will be going back and forth between a GIF that I found online. I'm not sure how it's going to look when we're looking back on this video that I post to YouTube. Guess we'll have to wait and see how that's going to appear. But here's hoping that the GIF will go across on Zoom without any issues. Yesterday, we mentioned the SA node. The SA node stands for sinoatrial. This is truly your natural pacemaker. There are plenty of people throughout this country and throughout this world that have to have a pacemaker installed within their body because for whatever reason, their own SA node, their own natural pacemaker isn't working properly. Normally, you should set a rhythm that sounds like lub dub, lub dub, lub dub, lub dub, lub dub. If you're just exercising, you're going for a run on Bayshore, you should sound like this: lub dub, lub dub, lub dub, lub dub, lub dub, lub dub. If your heart rate's really slow, lub dub, lub dub. I'll teach you what a rapid heart rate and a slow heart rate are and how it's not necessarily a cause for concern. But we'll get to that later today. But the sinoatrial node is located atop the right atrium. Its signals result in the atria. And when you guys hear me say atria, recall that it is not just one. Atria is the plural word for atrium. No one says atriums. You say atria. Its electrical output stimulates atrial contraction. Now, this is where you really need to apply what your quiz was on yesterday, the anatomy of the heart. Get into the game. So help me out. When the atrium, left or right, when they contract, where are they sending blood to? A ventricle. Okay. Now obviously the valves are tricuspid and bicuspid, but what's the one term that applies to both the bicuspid and tricuspid, given the locations in the bicuspid and tricuspid? AV. What does AV stand for? Why do they call a valve that connects the atrium to the ventricle an atrioventricular valve? Eva, you kind of look at me like, I mean, it's obvious. It's obvious. It goes between the atrium and the ventricle. That's why we call the atrioventricular valves. So you may call either one an AV valve, but when I ask you to be more specific, you need to say the tricuspid is on the right, bicuspid is on the left. So here's where we're getting at first. When the atrium is contracted, you guys just said that blood is going to be pushed out to the ventricles. So are the AV valves open or closed? I like how you paused and you thought about it for a moment, Jackie. She didn't just go, oh. She thought for a sec. Open. Obviously, if blood has to go from the atrium to the ventricle, the valves must be open. So something to remember is that when the atria contract, AV valves open. I was telling my last class that I actually have a couple students who do want to be a cardiologist. Maybe their parent is, or maybe they're inspired by something, whatever the case may be. When you guys are really getting into the thick of it in college and beyond, you need to have a mental image of a heart pumping burn into your brain. So you could just think back to your brain and you can think about, okay, how's this supposed to look? All right, the atrium is contracting, is pushing blood into the ventricle, the tricuspid is open. You need to really just recite how it looks in your mind. That's when you know you are studying enough. So when Jackie says the valves are open, that is true. The atrium contracts It pushes blood to the ventricle. And in order for that to happen, if I were to push Jack outside, out of my room, I'm going to need to open the door first for him to get out. You can't just have it go into a dead end. So when the atrium contracts, valves open. So let's look at the opposite of this. When the atria relax, the AV valves are closed. Okay, now if I can scroll up just a little, I want to go back again. Your SA node is right about there, where that yellow heart is, or it's yellow heart, yellow star. And the last little input, fun fact with the SA node, it's the pacemaker. It sends signals, which are electrical in nature, to the AV node. The AV node is far more powerful, has a much greater range of electrical signals, and it's going to actually get the ventricles to contract. Okay? Are there any questions on any of this so far? All right. Let's move on to the AV node then. What does the AV stand for? All one big word. Good. Atrioventricular. This valve is, or not this valve, excuse me, this node is near your tricuspid valve. It is stimulated by your SA node. When there's an issue with the AV node, you need to look and see if perhaps there's an issue with an SA node. If I'm not conveying information to Tyler appropriately and Tyler does horrible on the test, it might not just be a Tyler problem. It might be a teacher problem too, because I convey the information to him and then he conveys it and uses it on a test. So if there's an issue with the AV, it might mean there's something wrong with the SA, because the SA is what is responsible for the AV. This AV node stimulates the contraction of the ventricles. Okay, now yesterday when I saw Isabella and Eva walking in, they were looking at their notes, and I think one of you girls said that you've been looking at the heart all day, so it was like burning your head. So I hope that's the case for all of you, because it's going to really be needed right here, right now. I want you to visualize the ventricles filled with blood, both the left and the right. The ventricles are about to contract. They're like going to push. Where are they going to push the blood towards? Can you tell me the two places? Just got quizzed on this yesterday. I like that you didn't just jump. You thought about it. Go ahead. Aortic valve. Very good. The aortic valve and the pulmonary valve. So when the ventricles pump, blood is going to go towards the aortic valve and the pulmonary valve. Both of those are called semilunar valves. We can call those SL valves for our purposes today. Are those valves going to be open or closed? Very good. So what you need to get here, when ventricles contract, SL valves, what does SL stand for? Semilunar, that's aortic and pulmonary. I'll squeeze that in just for in case you don't recall. Aortic and pulmonary, those are both SL valves. The SL valves open. You have to push the blood forward. Okay, but let's go back. Visualize the heart in your brain. When the ventricles are pumping, what valves do you want to have closed so that you don't have backflow? What are both of those called? I know, but the one word that you can use for both? AV valves, yeah, help each other out. So this means that the AV valves are closed. Well, hold on. When a chamber contracts, its valves open. If the AV valves are closed, then what part of the heart must be relaxed in order for the AV valves to be closed? Yes. This is because the atria are relaxed. There's a lot going on here. And every cardiologist, every doctor starts somewhere. This is where it starts. The atria are closed, or excuse me, the atria are relaxed. The AV valves are closed. The ventricle contracts, the SL valves open, and it pushes their contents forward. So I'm going to pause here for a second, and I'm going to try to switch over to a GIF. And this GIF is going to be constantly in motion. A GIF is like a little animation. I don't know how this is going to look on the Zoom video. Hoping it works out. No guarantees. So let's switch on over. There we go. I hope it's going to look good on YouTube. I'll have to look back to find out. There's a lot going on here in this image, but what you guys do not see on this image is you do not see the pulmonary valve, and you do not see the pulmonary trunk, and you do not see the pulmonary veins and arteries. So I'm just putting that out there. You don't see the pulmonary trunk, you don't see the pulmonary valve, you don't see the pulmonary veins and arteries. What you do see on this GIF are the left and right atria, the left and right ventricles, the tricuspid, bicuspid, both called AV valves, and you see the aortic valve, which is the semilunar valve, and you see the aorta. So rather than me going to a screen, because that's not going to help anybody at home, I'm going to have to sit here and I'm going to use my pen to point to some things. I want you guys to tell me what I'm pointing to so we can get a point of reference, okay? What is that? Right atrium. What is this? Tricuspid valve. What is this? Very good. What is this? Left atrium. What's this? Bicuspid. Another AV valve. What's this? Left ventricle. What's this? An aortic valve, also a semilunar valve. And what's all this? Okay, good. Now, what is this node up here at the top of the right atrium? That's your SA node. That's your pacemaker. I want you to notice something. There is a lot going on here, so we have to take it just piece by piece. I want you to notice that when the SA node fires, an action potential is like that little lightning bolt of energy and electricity. I want you to notice that both atria contract. When you hear me say the atria contract, it's basically pushing the blood out. If those are contracting, what is happening to both AV valves? They're opening. When the atria contract, the valves open. And where will blood be pushed to when the atria contract and thereby opening the valves? Ventricles, okay? Follow along now. Once the blood is in the ventricles, what happens to the atria? No, the atria, not the valves, the atria. They relax. And when the atria relax, what does that do to the valves? Closes them. Good, 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 good so far. Now, I want you to go back to the SA node. Where is the SA node firing to? That is right, the AV node. And notice the path of the electrical action potential that is traveling down the middle of the heart, and it just almost surrounds the ventricles. This is a very powerful contraction, and it causes the ventricles to push with a lot of force the blood out of the heart, whether it's going to the lungs on the right side or going to the body on the left side. When the AV node stimulates your heart to contract, what chambers are actually contracting? Think about it. The question was, when the AV node is firing its action potentials to your cardiac muscle, to your heart, what chambers is it stimulating the contraction of? I'm here in atrium, I'm here in ventricle. What node, look at your notes that you've done so far, what node is responsible for your atria contracting? The SA node. What node is responsible for your ventricles contracting? The AV node. So in the AV node, that second one right here, when it fires, look, it's whoop, all over. It's forcing your ventricles to contract. Okay, now if the ventricles are contracting, what valves should be open? The aortic valve on this picture, and what valve is not depicted on this animation? The pulmonary valve too. Okay, and remember that when the ventricles are contracting, the atria is relaxing. If the atria is relaxing, then the AV valves are closed. Now, if you look down here, this is what I'm going to teach you next. I'm going to teach you that. That's called an electrocardiograph. It's a depiction of the rate of your heart, your sinus rhythm. So let's switch back over. I hope that video transferred well. Let's go on to the next part. And let's do electrocardiography. At the end of today's class, what I plan to do is I want to show you a video with various electrocardiographs, and I want you guys to try to diagnose what is wrong with the patient. Okay, electro means electricity. Cardio, what does that mean? You know that. Heart. And graph means image. So we have electric, heart, image. This is a tool that is used by a lot of clinics and doctors' offices and cardiologists to try to get an idea of how your heart is actually working. What's the rhythm that it's using? So you have electrical currents generated by your heart. These electrical currents can spread throughout your body. And can be detected by an ECG, which is an electrocardiograph. Now, some people might call it an EKG. Americans call it EKG too, because in several countries, namely like European, Germany, and so on, they spell cardio with a K. And so you might hear it called an EKG. It is the exact same thing as an ECG. I mean, it's just K, C, whatever. Practically the same thing. And what the doctors do is they apply leads, L-E-A-D-S. They apply leads to your body. There's 6-point leads, there's 12-point leads. And a 12-point lead is like a really sophisticated heart monitor. They put a lead on near each shoulder. They put a lead near each corner of your waist, left and right side. They put a couple on your lower body. And then they put about 6 of them. Like, look at me, like right here. 1, 2, 3, 4, 5, 6 on your chest. And that's all to try to pick up the electrical current of your heart. Like, guys, seriously, the electricity generated by your heart. And so this is where those multiple colors are going to come in handy. The first thing that you're going to need to draw is a line. This is going to be our x-axis. We're not going to really worry about a y-axis. But the x-axis is going to be time measured in seconds. We're going to have 0, 0.2, 0.4, 0.6, 0.8, 1.0. And before you can understand what a EKG or ECG is telling you, you need to know what the parts are. All right, so with your black pen or your pencil, let's start at a little before 0. We're just going to have a baseline. This is going to be rest. This is rest. And then we're going to have a minor wave. This is called a P wave. I will later explain to you what a P wave represents. We're then going to have a little bit of a rest. Then we have a minor dip. This is the S interval. Why did I say S? I'm stupid. PQ. Overwrite that S and put a Q. Sorry. Then go up. That's kind of a. Then go down. This is your R wave. Very, very powerful spike. Then it kind of dips down again. This will be the S interval. A little bit of a lag. And then we're going to finish it off with a T wave. And then the whole thing just repeats itself. It goes over and over and over and over. So this is actually really not that complicated. I'm not going to get into a lot of the electrodynamics of it all. I just want you to know what's generally happening in each part. I'll give you a moment to get this jotted down. I will then teach you one final thing, and then we're going to transition to an actual electrocardiograph and see if you can diagnose what's going on with the patient. Okay? You're going to put your doctor hats on. So first, let's begin with a P wave. A P wave is an SA node firing. It's electrical signal. What part of your heart tends to respond and contract when your SA node fires? Is it the atria or the ventricles? That is correct. So the atria contract. This typically lasts 0.1 seconds. 0.01. 0.01 seconds. 1/100th of a second. That's how fast it goes. Because your atria contract, what valves are opening? Good. AV valves open. Very good. So notice that the P wave really isn't that big when you compare it to R wave. And by the way, if you're wondering why did they say P? Honestly, guys, there's not a rational or logical explanation for that. Someone a long time ago, probably in the 1900s, developed this technology, and they must have been obsessed with the letters P, Q, R, S, T. There's really no reason why it's P, Q, R, S, T. It could be A, B, C, D, E. So if you're wondering why did they choose those letters, your guess is as good as mine. There's really no reason for it. So let's move on to the next part. We're going to combine Q, R, and S together to form the QRS complex. This is the AV node stimulating the contraction of what? Very good. The contraction of ventricles. Now, if the ventricles are contracting, let's get a few things down, okay? If they are contracting, what valves are open? Think before you speak. What do you call the two? Semilunar valves. Very good. SL valves open. What is the current state of the atria? Are they contracted or relaxed? Very good. And if the atria are relaxed, what valves are closed? Very good. Very good. Now, the QRS contraction is a major contraction. To prove my point, look at the difference in the spike. Look at the P wave versus the R wave. It's big difference. That just shows you how much juice is being pumped to make that heart pump hard enough to get blood throughout your entire body or to your lungs, whichever circuit it's on. Okay. And then lastly, we have your T wave. This is going to be the ventricles reset. And they get ready for the next one. All right. So we have about 20 minutes left. I'm going to teach you 2 more terms, and then we're going to apply them to multiple electrocardiograms. And you're going to play the role of doctor, and you're going to see if you can diagnose what's going on. All right. I will draw a couple, and then I'll switch over to a video. So the 2 other terms I want to teach you, and this will wrap up your new stuff, is Bradycardia. Bradycardia is a slowed down heart rate. Tyler is in cross country. I would not be surprised actually if we put a bunch of leads on Tyler's body to get a read of his heart, and if it was really slow, like slower than normal. He's a cross country runner. He's really in shape. His heart does not have to struggle to pump blood. Typically, individuals that are out of shape or overweight or lethargic, they have a rapid heart rate. And that's that is the #1 disease in this country is heart disease, because we have such bad food in our society and a lot of people kind of overdo it. Heart disease is the #1 killer of Americans. Well, when you're in shape like Tyler, who runs up and down Bayshore about every day, his heart does not have to struggle at all. So if you have someone who might be eating McDonald's every day, their heart's going to sound like boom, 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 boom. Tyler's is probably like boom, 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 boom. It's relaxed. It's in good shape. So an electrocardiogram that would look like his would probably appear like this, guys. So you can see the P wave here, QRS here, T there. P, QRS, T. P, QRS, T. I would expect that to be a good example of bradycardia. Now, the opposite of bradycardia is tachycardia. This is a rapid or fast paced heart rate. This is where you're like boom, 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 and that can wear out your heart. It really can. Your heart's struggling. It can wear it out. When I was in school and I was trying to figure out the difference between this, here's what I thought. And keep in mind, Tom Brady's been quarterbacking for a long time. He was a quarterback when I was in high school. So I would think how calm and cool and collected Tom Brady is in the backfield. Just relaxed. He knows what's going on. Brady is cool and calm and chill. That's going to be slowed down. And then tachycardia is just very, very fast. Here's what a tachycardia would likely look like. Oops. So you see how much faster it is compared to Tyler. P, QRS, T, P, QRS, T, P, QRS, T, P, QRS, T, and so on. So I'll give you 2 more examples of something that might go wrong. Then I'll turn off the recording and we will switch over to a YouTube video and see if you can diagnose it, okay? All right. I'm going to draw one. See if you can figure out what's wrong with it. You ready? Patient number 1. Here's what their electrocardiogram looks like. Something's wrong. Can you identify it? Look at where I started. Yeah, there is something funky with the T wave. You're right about that. What's that? Where QRS? Oh, I see. So you think the P comes after? Bingo. There's no P. If there's no P, what node is not working properly? This is an SA node that is non-functional. Very good eye. It could be a birth defect. It barely opens from the AV valves. Barely. So this is a P wave is missing. This is going to slow down your heart rate to 40 to 60 BPM. Your average, we did this the other day. Some of you were in the 60s, some of you were in the 90s. We're going to say the average is about 75 beats per minute. If you're down to 40 to 60, is that bradycardia or tachycardia? That's bradycardia. That's going to be slower than you should be. All right, here's patient number 2. This is where we'll finish it today. You're going to love this one. All right, you ready? Here we go. Isabella, you just kind of giggled. Why? It's all over the place. This is complete and utter chaos. This is disorganization. There's no pattern. There's no rhythm. It is totally random. What do you think's going on? Worse. This is a heart attack. The heart is not beating properly. It's all over the place. I mean, there's no predictability to it. There's no pattern to it. It is just completely random. This could be caused by somebody getting electrocuted. When you get electrocuted, not only are you getting zapped, but your own internal pacemaker is also getting shocked. And that's why when some people have a heart attack, their heart shuts down. We give them a defibrillator to shock them to try to jump start it back into rhythm. This is fibrillation. This is ventricular fibrillation. Fibrillation is out of tune, out of whack, not organized. A defibrillator is going to try to undo that and get you back into a proper groove. All right, so before I turn off the recording, I want to show you what YouTube video we're going to watch. So I'm going to switch back over to the internet just so you can see. Where did I put it? Here it is. So if you go to YouTube, you type in EKG training, watching and interpreting the defibrillator monitor. We're going to watch this and I'm going to see if you guys can diagnose it, okay? Let's turn this